So happy birthday, Katie. 1, 2, 3.
Happy birthday to you.
They're singing. They forgot the words. Okay. All right, Amir. Do you know how to say that in Arabic? Does anybody know how to say it in Arabic?
Yeah.
All right, come up here. No, just for staying right here. Quickly. All right. We're going to sing you happy birthday in Arabic. Okay? All right, come on over here. This is called Kareem. Kareem. Yeah, be quiet. Let him sing it. You just have to sing it. Just sing it just right here. Okay? All right. Go ahead. Just saying happy birthday. Just sing happy birthday. Hey, somebody. Mohammed, come up here. Mohammed. Okay. All right, Mohammed. Anybody else? Rauda, anybody else? All right, they're going to sing along with you. But anyway, let's do this again. You want to count? All right, 1, 2, 3.
سنة حلوة يا جميل سنة حلوة يا جميل سنة حلوة يا
Katie.
سنة حلوة يا جميل.
Hey, very good. All right, happy birthday, Katie. That was in Arabic. Okay, now. So, let's do the problem. I'll read it right off the paper. It says, Rose is sledding down an ice-covered hill, inclined at an angle of 15 degrees with the horizontal. So that means with the horizontal. So that's the horizontal, right? And that's 15 degrees. In other words, this is the horizontal. That's the horizontal. So it's going to be 15 degrees with the horizontal. Okay? You get that? Okay. So it's 15 degrees with the horizontal, or it should say 15 degrees above the horizontal. Okay? If Rose and the sled have a combined mass of 54 kilograms, what is the force pulling them down the hill? So that's going to be pulling them down the hill. So this is what it looks like. Okay. This is the, sorry, hold it. This is the, is that level? That's pretty level, right?
Yeah.
Is that good? Is that level? So that's the horizontal, and we'll say 15 degrees with the horizontal. So that's 15 degrees, right? Yes? Now, we'll just draw the sled and Rose as just one mass. Okay? So that's going to be one mass, correct? Now, one mass will look like that. Now, there's going to be three forces. There's going to be a force, and they're all from the center of mass, correct? There's going to be one force that is straight down. We'll draw it like that. Is that straight? Close enough? Is that all right? Okay. That's going to be the weight. The force that is perpendicular to the ground, perpendicular to the horizontal, is called the weight. That's FW. Okay? Then there's going to be a force that is perpendicular to the ramp. Okay? So you're going to say, this is perpendicular to the ramp. Okay? So this is perpendicular to the ramp. Not my finest drawing by any means, but it's going to be perpendicular to the ramp. Okay? And then there's going to be a force that is parallel, with the ramp. So do you see that this triangle in blue is the same triangle that's in black? So if you look at it like this, if you took the triangle, and you see that? That's a right triangle there. If you took that right triangle and you kind of twisted it like this, right? So that's the right triangle. Then this angle here would be that. So that's going to be theta. You see that? Now, the force that's perpendicular to the plane is called the normal. Remember the normal force when we talked about? Yeah. We talked about forces on a flat plane, remember? Okay. That's going to be the normal. And that's going to be the FP, or I like to call it the pulling force. Some people call it, some books call it F sub D, down, but I like to call it pull or push, depending upon which way you're going. If you're being pulled up the incline, then you're going to have it pull, and then if you're letting it go down, that's going to be the pull. Okay, pull or push. Okay, so and you know what that force is. If you're going down the stairs, it's an incline. You kind of feel that kind of like tendency to want to go down the stairs. You know, you feel that kind of pulling down in a way, don't you? Or how many people have ever been on a slide as a little kid? Okay, you go down the slide. You don't go down the slide as if you're jumping off the slide, but you go down slower, right? Because that's going to be less than if you jumped off it. So yeah, so that tendency to want to go down is going to be this. So you ready? You ready? This FP is that portion of the weight that is parallel with the plane. FP is that portion of the weight that is parallel with the plane. You get that? Fn, thank you for leaving that alone, I appreciate that. I think Jacob had it right in the first place. The Fn is that portion of the weight that is perpendicular to the plane. Clear? Now, we know that angle is 15 degrees. We want to find Fp, correct? So it just becomes very simple. What do we know? What do we know? We know Fw equals mg, correct? What's m? 54 kilograms, right? M equals 54 kilograms, so Fw equals 540 newtons, correct? Yes? We know that it's going to be opposite over hypotenuse. That's a right angle. The side opposite the right angle is the hypotenuse. So it's going to be sine theta equals Fp over Fw, correct? We know that it's sine 15 degrees equals Fp over 540, correct? Give me the answer for that. What is the answer? It's going to be sine 15. Make sure that it's in, and we're going to stop whistling, correct? What is it? 140 newtons. Okay, so Fp equals 140 newtons. And that's the problem, because it says, what is the force pulling them down the hill? And that's it. We're looking for Fp. So this triangle is critical. If you don't know that triangle, then there's going to be some major problems in doing Newton's laws in 2 dimensions. Clear? And we're off. Happy birthday, Katie.